technologies like solar drying, oven drying, microwave drying have been developed by Makerere University in Ofima. And protein-rich ingredients using different technologies like dry fractionation and wet precipitation, using IFA crops like cowpea have been developed by VTT, University of Pretoria, and Makerere University. And fat replacers have been developed by University of Pretoria and Kratos. And we have all these, the other ingredients developed by the other partners. So, using these pre-treated floors, using IFA crops, different food prototypes so far have been developed. So far, we have around 17 food prototypes developed by the partners that I showed you. So, for instance, we have expanded sorghum snack. We have different, in category-wise, we have pasta products, bakery products, and cookies, snacks, and instant porridge products. Developed using the pre-treated flours. So, taking the advantage of this workshop, as we are partners, AU and Getsagro are partners of this work package from Ethiopia. So, taking the advantage of this workshop, I would like to highlight you what activities we have been doing so far. So, AU and Getsagro, we have 4 person-months in this work package. So, since it's a small person-month, since the launching of the project, we merged our person-months and we have been working together. So our objectives, milestones, deliverables are in parallel with the objectives, milestones, and deliverables of work package 4. Basically, using the output from work package 2, the one that Dr. Gala presented, 2 important information have been extracted. Number 1, what are the highly consumed foods? Okay, highly consumed foods from the consumption that work package 2 conducted in Hawassa City and Addis Ababa. What are the highly consumed foods? So foods were selected. Number 2, what are the ingredients for those highly consumed foods? So using this information, we have developed a pre-treatment, for the selected raw materials for the highly consumed foods. Number 1, and using the pre-treatments after pre-treating the raw materials to produce those highly consumed foods, we try to improve the quality of existing highly consumed diets. Okay? So just to highlight you, the pre-treatments that we have selected were fermentation, germination for ethylene flavavin, hydrothermal treatment, or commonly it's called moisture heat treatment for ethylene flavavin. We have selected these processes, these pre-treatments using previous evidences. These processes are very minimal. This process provides safety to the food product, and they are highly acceptable by the community. They improve nutrient viability, and etc. So I borrowed this slide from Dr. Galab and from work package 2, of course. This is the output from the consumption survey in the 2 major cities, okay, Hawassa and Addis Ababa. So when you see the food consumption output, mainly consumed food items were pasta, bread, and porridge. And the major ingredients, mostly they were monotonous ingredients like wheat. So it gives us a good window of improvement for the highly consumed food items. So let me take you through briefly what pre-treatments we have applied on the major IFA crops for the highly consumed diets, highly consumed foods from the consumption survey. Okay? So the first pre-treatment we applied on the first IFA crop, F, is fermentation. We have applied the traditional way of fermenting F in Ethiopia. This is the way that we ferment F in Ethiopia to make the commonly stuffed sort of flattened bread named injera. But our objective is not to make injera. Our objective was, after fermenting for 72 hours and lyophilizing the dough, we want to use this lyophilized fermented flour as ingredient to improve the highly consumed food items. So this is the fermentation protocol, the traditional way that we use in Ethiopia. And we characterized the fermented dough for the different physical chemical properties, and we have seen some interesting improvement in functional properties. We have seen some enhancements in nutritional qualities like growth energy, total carbohydrate. And also one of the most dominant anti-nutrients in teff is, as we all know, is phytic acid. And during 72 hours of fermentation, there was significant reduction of the phytic acid. And following the reduction of this anti-nutrient, there was a tremendous significant improvement in increasing the major macro and micro minerals, and also viability of micro minerals. So, and when we see the surface morphology of the fermented teff, okay, as I told you, our objective is to use the teff flour as ingredient for the mainly consumed, to improve the quality of the mainly consumed food items. So, knowing the techno-functional property of the flour is very important, and we verify that also not only by analyzing the techno-functional properties, but also when we characterize surface morphology, the result also indicates that the fermented flour has the potential to be ingredient for improving the highly consumed diets. That's fermentation. The other pre-treatment we applied on teff was germination. I think for most Ethiopians, we don't use teff in germinated form for whatsoever food application. That's new. So, and the studies were also scattered. Okay? There are very limited studies on generation of teff, but there were few, and we adopted the method from this reference. And teff was generated for 24 hours, 48 hours, and 72 hours. Since it's new, we want to see also the effect of the time kinetics on the quality of the grain. And the germinated teff was lyophilized. And let me show you the closer look of the germinated 72 hours germinated teff. It's very unique because of the small size of teff. And the germinated teff are different hours of germination. They're characterized for physical chemical characteristics. And unfortunately, we didn't see that much significant reduction in anti-nutrients, like compared with the fermentation. And we didn't see also that much change in nutrient enhancement. And for functional properties and mineral concentration, the germination didn't show a significant improvement. And the other pre-treatment we applied on teff was hydrothermal treatment. The method was adopted from INRA, our partners from France. And the hydrothermal treatment was done for 48 hours, 0, 2, 4, 8, 16, 24, 30, and 48 hours. And along with the kinetics, we have tried to characterize the physical chemical properties of the hydrothermal treated teff at different hours. And the crude fiber concentration has been enhanced during, along with the kinetics of the hydrothermal treatment. And there was a significant reduction of the phytic acid, okay, along with again the time of hydrothermal treatment. And we didn't see that much significant change in iron and zinc concentration, but calcium concentration has been improved during hydrothermal treatment. So, compared with fermentation, germination, and hydrothermal treatment, for teff case, we have selected fermentation of teff or fermented teff flour with better functionality, with better nutrient enhancement, with better micronutrient bioavailability. We have selected fermented teff to be ingredient for the targeted food prototypes improvement. And the other IFA crop that we tried to pre-treat was fava bean. And the first pre-treatment we applied was germination, and the protocol was adopted from these two references. And the fava bean was germinated for 72 hours and characterized for physical chemical properties. And of course, the germination for 48 hours, germinating fava bean for 48 hours has a good impact in improving concentrations of minerals like calcium, magnesium, and potassium. And when you see the techno-functional properties of the germinated 48 hours germinated fava bean, there are improvements in functional properties like blood density, oil, and water absorption capacity. And interestingly enough, the phytic acid reduction was significant also. The other pre-treatment that we applied on the fava bean was hydrothermal treatment or moisture heat treatment. The method was the same that we applied for TEF. The kinetics is also the same, and it was adopted from the method developed by Ingra, partners from France. And this is the morphological appeal of the hydrothermal treated fava bean at different hours. And these are the soil oxide. And let me show you the physicochemical characteristics that we have done on the hydrothermal treated fava bean. Phytic acid concentration was significantly reduced at the time of hydrothermal treatment increases. The phytic acid reduction was significant. We didn't see that much change in crude protein concentration, and there has not been any significant change in iron concentration, but similar with the hydrothermal treatment tape, the calcium concentration has shown significant improvement. So for fava bean, for tape, we have chosen fermentation, and for fava bean, 48 hours hydrothermal treatment have shown better functional, nutritional, and micronutrient. So we have selected 48 hours hydrothermal treated fava bean as ingredient for the food prototypes, those that we selected for improvement. From the consumption survey, the 3 food prototypes that were highly consumed and we targeted for improvement were bread, pasta, and porridge. They were made from monotonous crops. Okay, monotonous crops. Usually, the bread is made from wheat, pasta is made from wheat, and porridge from 1 or 2 types of cereals. So we targeted these food prototypes, okay, using the pre-treated flows, fermented tape in 48 hours hydrothermal treated fava bean. And our objective is to produce nutritionally enhanced and healthy food alternatives. Okay? By healthy, we mean food products with low glycemic index, food products at least, if possible, gluten-free, but at least to reduce the gluten to acceptable level. And last but not least, we are very sensitive to sensorial acceptability. The food prototypes that we plan to improve need to be sensorially acceptable. So we are at this stage now. We are now working on optimizing the food formulation, and now currently we are working on the formulation of the bread and the pasta. These are just preliminary pictures that we have formulated. Okay, this is the pasta formulated from fermented egg and germinated fava bean, and this is the bread made from egg and fava bean. Of course, wheat being the major ingredient. So we are at this stage now, and we are working on it. And in the coming 2 or 3 months, we'll finalize the food process, the food prototype development and improvement. Way forward from what we have done so far, Health Cycle Industry and at the university will try to develop or optimize the final food prototypes in the coming few months, and we'll characterize the nutritional and functional and sensorial properties of the food prototypes. And last but not least, like Dr. Kala mentioned at his final slides, simulating scenario where bread, pasta, and porridge are replaced by the healthier formulations, by IFA crops or IFA formulations, will evaluate the potential health or nutritional impacts. I would like to, before I wind up the presentation, I would like to acknowledge the European Commission. This project has received funding from the European Union, and I would like to thank, on behalf of our center and AAU, I would like to thank the Commission for that. I would like to thank AAU and AAU administration and Health Cycle Industry and all Work Package for partners. And I would like to thank Work Package 2 because our performance was low, but Work Package 2, by any means they have been helping us. Thank you for that. Thank you.
This work package is to valorize the biomass residues from raw material harvesting and food processing via bio-based packaging innovations to reduce food loss and increase the efficiency of the food system. In many African countries, plastic bags and packages are banned to relieve plastic pollution and microplastic issue, since conventional petroleum-based plastics such as polyethylene takes hundreds of years to degrade. In this project, we want to develop packaging materials which offer sufficient properties to store goods and increase the shelf life of the products without being environmentally harmful. We approach this issue by using renewable-based polymers and harvest crop side streams to create fully soil and marine degradable and microplastic-free biocomposite packaging materials. Besides the properties and eco-friendly label, materials should be processable with the same machinery as conventional plastics and without complex chemical treatments, so that it can be implemented in African countries such as Kenya, South Africa, Uganda and Ethiopia. We contribute to development of new value chains and income sources to local farmers. What is side stream then? We consider this as what is overground, non-edible parts of the material to minimize the impacts of the food side production to avoid the use of feed, by avoiding the use of feed material as well. This picture is only for illustration purposes. We started with the hypothesis that African crop side stream can be used as a reinforcement in bio-based and biodegradable polymer composites, and so far this has been true. Side stream selection viewpoints that we consider are that can we process it, is it available, and how is the availability supported by the needs. And we evaluate these factors as part of the value chain development with other packages to higher value products. And as mentioned, in this VP5 we work to convert the low value agricultural side streams into higher value products. The harvest residue side streams of fava bean has currently been used as a filler in bio-based and biodegradable polymer matrix, which is an important crop here in Ethiopia as well. And demonstrating the processability and properties of this side stream reinforced polymetric material, which can be used as part of this packaging material. Why fava bean is a good starting point? We did a survey in the beginning of the project that showed that Ethiopia has largest side stream availability for fava bean among the global crops. The production is about 375 kilos per 0.125 hectare per year in Ethiopia, and demonstrating the processability and properties of this side stream reinforced polymeric material is an important issue which was studied by one partner of University of Pretoria in South Africa. Then for the polymetric matrix selection, two bio-based and biodegradable materials were chosen. This polyhydroxybutyrat covalent PHBV belongs to a family of polyhydroxyalkanates, and it can be produced by a microbial activity. That is nice in that way that it does not require any industrial composting facilities to degrade, and it has excellent water vapor barrier property among many biopolymers. There is a drawback with this polymer that it's inherently brittle and lacks melt strength during melt processing, and for that reason we mixed it with PBSA, polybutylene succinate co-adipat, which is partially plant-based biodegradable polyester, which has good flexibility and processability, and by mixing in nice ratio these two polymers, the legislation changes that are against fossil plastic uses will put pressure on development of these new novel alternatives, which increases the demand of these polymers, and also we get so. As previously mentioned, fava bean side streams were dried initially to prevent degradation of the mold and material growth, and the first step in the composite processing was milling for these side streams. They were milled to under 2 millimeter length scale to improve the dispersion into the polymetric matrix. And the large particles would lead to clogging in the processing equipment, and that was one of the reasons why it was done. The milling could be carried out by grinding the machinery by using certain existing granules if available, or some minor additional components that are there. Milled fava bean was then mixed physically with this PBSA and PHBV polymers by twin screw compounder and pelletized for fields are commonly used for processing in conventional plastics. And then the samples were prepared by injection molding and cast film extrusion to determine the effect of this side stream content on the properties of these plastics, and then the results of them can be shown in the bottom of the slide. Basically, the processing temperatures of 165 degrees lower than temperature of typical processing conditions, and that can lead to energy savings during processing. And as seen from the images, the high side stream fiber contents contributed to darker color, and the melt strength of material decreased as a function of increasing fiber content by compounds like pods and stems, and the mixtures were used to see are there differences among these, to see the value proposition of these materials. And the amount used in these was, as mentioned, 10 to 30%, which is already a good quantity. All of the samples were able to be injection molded, and to sort of conclude these to having these in more complex shapes, we will try to test what we can do with those. But to conclude, African crop side streams can be used as a reinforcement, bio-based and biodegradable polymer composite, and the processability and reduced need of plastic product import and creation of export products can be replaced in part by this our side stream containing solution, and even create products from them. And we can avert some food loss. The improved shelf life provides better packaging, and that can help food losses, and also reducing need for food imports in later stages. The developed materials are more durable ones, and in addition, more from the same land can be obtained, and more jobs can be created. So thank you for your attention. I hope I didn't take too much of the time.
Thank you, Dr. Rene.
With stakeholders who can be able to take up this technology. And that is why we are developing the innovation platform, so that we can have an impact. We want to make sure that the diets are improved. We want to make sure that people in rural areas, urban areas, are getting healthy food. Here is a model of how this innovation platform would look like. I had made this presentation for work done in Kenya, but when Alemu gave me a chance, I said then I would just use a similar one. But if we would put Ethiopia instead of Kenya, we're neighbors, so we're good friends. If we just put Ethiopia, we can see there was work presented on production, there was work presented on processing, there was work presented on work package 1. That is what we are doing in InnoFoodAfrica. We are looking at smart processing. Okay, we are optimizing the processes to ensure we reduce phytate, for example, to ensure we have fava bean that can grow in areas that it hasn't been growing well. So there's a lot of smart processing, smart production. Yane just presented about the potential of bio-based packaging, really huge potential in that. So we're looking at all this. We're going to have the diets, we're going to have the recommendations. And what we're going to do is, we're going to put together a platform where in the center is all the people involved in the project directly, all the partners that Raya presented, they're in the center. And as you go to the other circles, we have the stakeholders. And what the platform will do, it will be the one-stop shop, if I would put it that way, where when you come as a stakeholder and you are interested in some of the work we're doing, through the platform, you will be able to get all the information you need so that you can be able to take up the technology. You will be linked to the right partner. If you're a food processor, then it will be AAU. If you're a farmer, then of course it will be ARA, for example. And that's why each country is represented in Kenya, Uganda, Ethiopia, South Africa. However, the InnoFoodAfrica project also had the vision of creating markets, not just locally and across the countries, but also internationally. There was an issue on gluten-free products. That's a big market, even in Europe. What if there is a stakeholder who would be interested in TEF and some of the work that is being done in the AAU? So that we can be able, through the platform, connect them to what is being done in AAU. So this is the vision of the platform, to take all the technology we're developing, put it together in a nice package that can then be used and marketed. So we want to facilitate technology transfer. We want to act as a marketing channel, ensure that the stakeholder is connected to the right person who can then provide them with the information necessary concerning the technology that has been developed. And we also want to look for funds for the future. The European Union and other funding agencies are going to have funds in the future. Some of them may be to address questions that have already been addressed in the research we have done. And if we can partner with the right stakeholders, we can take advantage and make sure that we can apply for the funds that are then needed to pilot or to test the technologies. There is some, for example, funds that are being provided if the technology is already at a readiness level whereby it has been piloted but now needs to be tested in an environment where it would be used. There is funds for that, for example, and we need to explore such opportunities. So this was my 5 minutes to tell you about what we are thinking and what we are doing, and I really thank the organizers for this opportunity to tell. Thank you. That I've been given today. So there was several presentations, and maybe you had a question or something was not clear. So we want to give you a chance. And the speakers that were here, please be ready. If there's a question, I will then invite you to come and answer. So is there anyone with a question that you would be interested to ask? And you can ask from any of the presenters that were here. Anyone?
Can the presenters ask? Your figures showed reduction of phytate by these various processes that was statistically significant. But it went from, say, 250 milligrams per kilogram to 235, 220. In other words, we're looking at less than 10% reduction in phytate. So it's statistically significant, fine. Is it biologically significant? Does it really make a difference, that small a step? Or do we need to go for something bigger?
It's like you mentioned, it's statistically significant. The reduction was statistically significant, and we don't do any experiment to confirm whether it's biologically significant or not. But what we anticipate is when you see the mineral concentration, okay, the bioavailability of the minerals. When you see, for instance, the iron to phytic acid ratio, the zinc to phytic acid ratio, the calcium to phytic acid ratio. Those ratios indicated that the improved bioavailability of those microminerals. So at this point, what I can say is there is a significant reduction of the phytic acid. The processing techniques that we have learned have reduced the phytic acid statistically significantly, and that was more illustrated by the lower. That was illustrated by the anti-nutrient to mineral concentration, which lies within the expected range. That's what I can say.
Thank you. I don't think that fabism is not an important problem in Ethiopia, but Ethiopia is second to China in the production and export of fabamine, so it affects the international market. So why you didn't include vaccine convincing content, and also most importantly the oligosaccharides, which are known in Ethiopian context. Even there is a proverb like and that's an important component, the oligosaccharides. So why you didn't include this is a very important component, I think. Thank you very much.
Okay. The question raised at the beginning of the project as well. The answer is very simple. We don't have the facility to determine the VCN and co-VCN. And because of that worry, because we didn't determine the VCN and co-VCN concentration in fabamine, we are not targeting the fabamine, the pre-treated fabamine. We are not targeting it to improve the quality of the complementary food for children because it causes failure, right? So we targeted the hydrothermal treated fabamine, 48 hours hydrothermal treated fabamine for adult foods. So with that anticipation, okay? So we don't have a facility. That's very, very simple. The oligosaccharides, yeah, that we do. That we do. Because we now, there are some technological problems we face here and there. the oligosaccharides. At this point, they are not our bottlenecks to evaluate whether this treatment has a good effect or not. They are not indicator parameters, but once we start the product development, we will analyze that.
Okay, and let's
give us very good information on the food process actually. So my first question was to the first presenter regarding the value chain analysis. When it comes to the maize, for example, the major problem we have is the value chain is very long. Starting from the farm to the consumer is very long, and it has lots of problems. It has a price problem. It has also a quality problem, like aflatoxin, for example, in maize. So, what mechanisms have you designed to shorten this value chain of the producers? The second question I have is the linkage. The linkage between the processors and also the farmers. Have you considered or have you worked on that? And I just want to have some information on that. The second question goes to the other question goes to the second presenter, Dr. Karab, regarding the malnutrition. Malnutrition is a very serious problem, especially in Ethiopia. Ethiopia loses about 60.5% of its GDP annually. The studies show that one. And also we have the stunting problems, the wasting problems, and all problems we have. For that, the government has designed a national food fortification program. And it's working on 3 products like edible oil, wheat flour, and also edible salt. We are starting fortification, and also we have mandatory standards for these products. So how are you going to link this work with the national food fortification program? How is that attachment on that one? The last question goes to Dr. Pavlos about germination and fermentation. Actually, in baking, the germinated grains are sometimes they have a problem in baking. For example, when you germinate wheat or when you germinate flour, the enzymatic activity increases the product, and the baking is very difficult in that case. So, have you put a system or a design or whatever to prevent the enzymatic activity so that your baking results will be very good? So, I just want to have some explanation on that.
Okay, thank you very much.
Legacy, and in terms of its long value chain aspects, that's in terms of quality and price issues are mentioned there. So I think the quality issue will be answered by the application of proper storage structures and mechanisms. And if it's beyond that, even there may be a probability of application of some chemicals to protect it. Otherwise, it could be simply improved by using appropriate storage mechanisms. And in terms of linkage, I think as it is presented, it can be improved through the coordination and establishment of innovation platforms, as well as proper linkage mechanisms of actors or stakeholders. Concerning the price issues, as I have mentioned earlier, farmers such as the fertilizer factory should be established, and even in the study areas, the participation of the private sector is so minimal. So by involving private sector as well as the proper inputs for the buying and selling, importing aspect of the regulation issues, the policy issues should be properly revised, and the government will take that part, I think. Thank you.
For that, I invite Khalil, if you could please come and address the issue of malnutrition and the work being done on fortification, and is there anything we can do to link what we're doing with what the government is doing on fortification?
Thank you. Yes, that's a very nice question, and coming from the right person as well. We will be optimizing the diet to see what is possible with the foods, but definitely from experience we know that some of the gaps in nutrients will persist even after optimizing. And so our work will be highlighting what is possible by shifting within the diet, by integrating new food products. How far can we go? And then there will always be some gap, and by quantifying that gap, then I think we can contribute to the National Food Fortification Program in determining what will be the effect of the fortification, what should be the dosage, the most appropriate dosage for this urban community, although the national food fortification is usually done at the national level, but still it will give you a perspective of the gap that could be filled in urban areas after even optimizing the diet. I think that would be a nice link between the two.
Thank you for the question. If I'm understanding the question very well, you are saying that if we use the germinated fava bean as ingredient for the bread formulation during baking and dough making and proofing, it might produce some promise, right?
Yes.
Okay. That one we didn't look at it because for maybe if you have seen my presentation carefully, for bread formulation, what we have selected was fermented tape and 48-hour hydrothermal treated fava bean, not germinated one. So in case of hydrothermal heat treated fava bean, because it was a 48-hour heat treatment, we don't expect as such enzymatic activity at that hour of the treatment. So it's not germinated flow that was selected for bread formulation.
But just to add on that, by the way, Paulus, isn't it the wheat would be the problem if you have a lot of enzyme activity, and of course now you have the fava bean. So the pre-treatment of this flour that is pre-germinated for baking can be used actually to adjust, for example, actually if the wheat flour has the quality of enzyme activity is low, you could actually use it as an improver. But that needs to be studied in more detail to see actually could it actually be an improver, and that actually could be quite something because it's quite expensive when you import these improvers for baking. Thank you very much.
From just as I introduced myself earlier, I'm from International Potato Center. Just I saw orange flesh sweet potato in in all of the presentations. That is really very nice. Our organization, International Potato Center, is mainly working on root and tuber crops in Ethiopia, focusing on potato and orange flesh sweet potato. So this is orange flesh sweet potato is one of the most nutritious crops. It's fortified, vitamin A rich crop. So when nutrition the point, yes, the orange flesh sweet potato can come at one of top crops. So in the first presentation, I saw just there's no orange flesh sweet potato production in those areas. That's not surprising. Actually, these are lowland and midland varieties. So we recently are introducing this orange flesh sweet potato varieties, including in Mara region. We have different projects for this. So just this possible to collaborate with this project is we have offices in Bahar Dar, and for a long time we have been working in SNN PRBGs and also in Tigray region, and so these groups are actually more widely produced, especially in SN and DPR region. So I want to bring to the attention of especially the here agro industries for the processing of these crops. So I have one question for Dr. Fred. Just I saw presented Dilla is 1.5 times more productive than Kabode. So, but in our research finding, Kabode is one of the most productive varieties among oranges. So what I wanted to ask is how frequently you repeated your experiment. Is it only a single season research, or maybe you repeated over location and over seasons to come up with this finding? Thank you.
Otherwise, it's widely known in our region. When it comes to carbonate, it's a fact that we have planted around 5 varieties of sweet potato on 4 farms. So, as a rule, in our plantation experiment, there's no way that we go to 1 year. So, we evaluated that for 1 year, and we have also assessed the percentage of survival. So there was no wrong with plant population, and this proves that the growth was by far better than Kabode. And don't believe that Kabode gives or performs better than what in the other countries. It's true also in Southern Ethiopia, I have a recent publication that Dilla is by far better than other varieties. So this shows that it depends on the locality. So in one locality, Kabode may be perfect, and in another locality may be reverse. Actually, Kabode is not also prepared by farmers for its test.
Okay, thank you very much for that. The first one, I think I have seen many barriers and solutions in a list of bullets. I think it's good, to maybe reorganize in a way that we can understand better. For example, across the value chain, barriers and solutions. And my questions there is, there are recommendations to intensify the production of those crops. And the other way, we have also problems of soil fertility, degradation. I don't know how you can balance these things. We have to look into both aspects and then give a recommendation. For the second question about this malnutrition and overweight, I think maybe, I don't know if it is already discussed, but my question is, the malnutrition can rise, within a given period of time. A month, if the price of, some food items go up, like we have it, this time in Ethiopia. How do we really say, on this issue? How do you look, this scenario in terms of recommendation? The third one is for work package 3. Yeah, 2 times, 3 times fold of, productivity increase of this, farmers participatory research. Yeah, I don't know, someone was saying, one European, German, which was working with me, was saying, is there any country in the world where, you can double yields, using, small plow like Malaysia, and even Dr. Fred was amazed, on the probably, 3-4 increase in the small plow. It can also happen, across the country in many potential areas. I don't know if you have any recommendation to say, how you can advise, government or policymakers and what have you. The work package 4, the food prototypes which were select bread, pasta, and forage, pasta from TEF. I was wondering, I had a visit in Italy where a big company producing macaroni and pasta from TEF, even exporting from Italy to another country. I don't know if you have any experience in Addis Ababa University, because it's a low gluten product and maybe highly acceptable. Even the strings of pasta for cooking is far better than macaroni from Germany. Yeah, these are my questions. Thank you very much.
The previous slide, I said that there is a problem with the tool, and there are some repetitions. So the problem arises from the repetition of the tool, the questions, the checklist or the question. So it needs a re-summarization of results and all the other things. As to the third question, intensification versus soil property. To our suggestion, intensification is possible. Crop intensification in one district, that's a potential for maize, water, and other crops. But concerning banja, it is highland acidic and soil problematic area, so it needs soil amendments, so intervention through organic as well as inorganic fertilizer application. Otherwise, crop intensification is difficult in banja, in the acidic area. First, it needs reclamation of the soil rather than intensification. But in the potential area, it could be possible to intensify crop production system. Thank you.
Thank you very much. And then there was a nice question about affordability and how, in a day, people can compromise their diet, and we can see that with the challenges we've had in Ukraine. I think food prices are increasing. So, how can we deal with this need?
Again, it's a call for multi-sectoral intervention to link the food system, make it more resilient. I think that's also very important given what we are seeing globally with the disruption of supply systems, with COVID first. We had also a conflict on top of that, plus now the Ukraine conflict. All of that is making it very difficult to eat healthy, even more difficult. There are efforts to look at the cost of diet and how that has increased over time and what are the implications of these shocks in terms of increasing the malnutrition rate. Predictions are there, but I think we need a very serious evaluation within the country given that we have a much higher food inflation rate. And also this food inflation rate is not proportional for the different food groups. Usually the staples are quite stable, but then you've got nutrient-dense foods like fruits, veggies, where the inflation is even higher, so we're even deterring consumers to consume them. Some studies years ago we've done, we looked at the inflation by food group and we realized that cereals, sugar, etc., the price was going down relative to general inflation, whereas nutrient-dense foods were going up. So basically that's directing already the population to eat towards, to adopt an unhealthy diet. And so it will have implications in terms of rate of malnutrition.
In a nutshell, let the farmer decide. Give the farmer the information. Let the farmer decide. We have seen this in many parts of the world, and there are different responses for different types of crops. The bosses, the grain unions in particular, seem to hold on to their farmers, especially strongly. Farmers are very reluctant to give up chickpea land races in North Africa, for instance. The flavor, the food quantities are right for them. And the introduced materials may be all very wonderful, or all other sorts of properties, disease resistance, yield, and so on. But apparently they don't taste right. Now, in the case of our fava beans, we have a very specific stress in terms of soil acidity. I don't know what the soil acidity response is of the local check, but given what we have seen for soil acidity responses in other situations, it may well be that our 2.7-fold is huge differences in a property like that. Let the farmer decide is also my principle for